Morning, everybody. It's Thursday. That sounds like a kids' TV show, doesn't it? Thursday. Um, so, what we're going to do this morning is start looking at some loci in the complex plane, which is always very fun. So, just to get going, can you come up with any two vectors you like? They're vectors that start at the origin. And can you draw for me both of the vectors on your diagram, and then can you try and think about what a minus b means, and then can you have a think about, and I'm not absolutely convinced you'll know this, but have a think anyway, have a think about what the modulus of a minus b might be. So draw those vectors, draw the vector a minus b, and then think about what I might mean by the modulus of a minus b. So have a quick go at that now, pause the video and come back to me in a minute. Okay, so hopefully what you've done is drawn something similar to this. You've drawn a vector A, you've drawn a vector B, and then you've done a line, I've done mine dotted, to show, you don't have to draw it dotted, to show A minus B. This is written sort of back to front really, isn't it? Because we're doing minus B and then plus A in terms of the vectors that are already on the page. Obviously if we went out this way did A and then minus B, we'll get back here still, but that's not particularly important right now. So the fact that minus b plus a gets us from what would be, well, this point, let's call this point b, to this point a, is quite important. So in terms of modulus, if you think about what we've done so far, the modulus of a complex number is the distance it is away from the origin. I know these are vectors, but vectors and complex numbers in the Argand diagram anyway, behave essentially very similar to each other. This could be some complex number here, and we can think about the vector to it just being the complex number, as in you go a certain amount along the real axis, and then you go a certain amount up the imaginary axis, similar with B. Because this just tells you generally how far it is away from the origin, this sort of tells you the length of the vector. So if I had the complex number, for instance, what did we have a lot yesterday? We had 1 plus root 3i, for instance. 1 plus root 3i, if you think about how far that way is from the origin, you square both the numbers and take the square root, the distance is 2. The length of that vector would be 2. So in terms of what this means in vector notation, these modulus signs just mean the length of the vector. Now, I don't know if we covered that in GCSE or not. You definitely haven't done it in A level yet, but this means the length of the vector. So, what this means in general is what is the distance to A from B. That's really important for what we're doing today. This notation is what is the distance to A from B. So the first thing from the second one, and it's important that this negative sign's in there. If that was a plus sign, that wouldn't mean the same thing. You can draw yourself a diagram to show that that's true. But it's really important that we remember, and I'm saying it for a third time, that this notation means what is the distance of A from B. Okay, so let's just try and take that to a less vector place and more of a complex number place. So if I said to you, draw me an Argand diagram, which you guys can do, and I want you to plot 1 plus I. So let's say here's 1 plus I. Let's just be a 1 should accept the imaginary axis. Oh no, we'll put an I. I'm not sure what the convention is now. I think it's probably I2, I3, I. It is actually. Okay, so that's 1 and I. So if I said to you, draw me this, z, take away 1 plus I. Just match this up for a second, what we've got up here. And let's say equal to a half. So we said we could think of z as some vector. I've got the minus sign. 1 plus I, so there's a vector there coming up to there, that's that vector, is equal to a half. Now just go back to what we said about this. This means, what is the distance? What means the distance even, that would be better, the distance of A from B, and that's points. So this must mean the distance of Z from 1 plus I is a half, because it's equal to a half. Okay, we don't know what the value of Z is, per se. In fact, actually, there's very little constraint on it at the moment. The only constraint is that it must be half a distance away from 1 plus I. I mean half as in is 0.5 distance. So that must mean that I could have this bit here, Z could be there. There you go, that's halfway. There's another one there. And if you hadn't already guessed, if we keep going halves all the way around, eventually we're just going to get a nice circle around, oops a daisy, oh that's not too bad. I get a nice circle round 1 plus I, and the radius of that will be just a half. So this idea is really useful for when we're trying to do like I in the complex plane, because that's how we can think about it. We can rethink about it as vectors. You can think about it as well in terms of translations. Think about how functions translate. If you take 2 away from something, it goes to the right, for instance. Obviously, we've got an uppy-downy business going on here, but you can think about it in that way too. But I think this is the easiest way to do it, thinking about the distance of this from our original point is however much. So let's just try a different one. Let's try 2 examples, and I'm going to try 2 examples because people make quite common mistakes with these things. So let's try now, draw the loci of Z. Let's go for minus 4 plus 3I is equal to 3. So Z minus 4I minus 4 plus 3I even. So what I'd like you to do first of all is just have a think. What's the centre of this circle going to be? Okay, so the most common thing people do here is they see a minus sign and say, oh, it's Z minus 4 plus 3I. However, that minus is only acting on the 4 at the moment. It's not acting on the 3I at all. And so you have to be really careful with these, and you have to immediately write them. And I've written this in brackets on purpose up here to show you this. If it hasn't been written in brackets, what I want you to do is write something in brackets. Because if you've got it in brackets, then whatever you've got, the minus sign on here has to distribute over it, and you definitely know what's the centre of the circle. So let's make sure we have some brackets here. So minus 4, that still works. However, this would have to be minus 3I for when that minus distributes over the bracket. So we get Z minus and then 4 minus 3I. That's the complex number in the bracket, so that's going to be the centre of our circle. So if we're to draw that, I only need the first quadrant again. Picking them well at the moment. So 4 minus 3I, I keep putting this ruler on the table, I don't know why I keep doing it. Oh, well, I don't need it for a bit. 4 minus 3I, so 4, let's say it's about there, 3 about there. So there's the centre of the circle. 4 and 3i. And we've got a circle of radius 3. So we know that it's got to touch here and it's going to come to about there. So, zoop. I've drawn better circles. Okay, you don't need to write what the radius is in this. It's obvious what the radius is. It's 3 because it touches the x-axis, or sorry, the real axis. If it doesn't touch one of the axes, I would probably suggest you just do write a little line in, write the radius in, so people can see that you really do mean this. Generally, the examiners are pretty lenient with it. However, you're also trying to demonstrate that you know where the centre of it is. You're trying to demonstrate that you know it's a circle, and you're trying to demonstrate that you know it's a circle of radius 3. So just think about all 3 key points there and make sure that those 3 things are obvious to the examiner. And let's just try one last one. This is the other one which sometimes gets people confused. Not quite so often as the previous one, but it's still worth pointing out. And it's still one where I want you to set this out a particular way. And you probably won't see it set out this way in your textbook or anywhere else. But I do think it helps. So if I had instead x plus 5 is equal to, let's say 3. X plus 5 is equal to 3. Why have I written an x? It should be a z. So I've got z plus 5 is equal to 3. Then you need to say to yourself, okay, well, I do the same thing as before. Z, I need to have a minus sign here. And if I've got a minus sign there to get a positive 5, I'm going to have a minus 5 in here. And then please can you write in plus 0i? I know that seems probably a bit of overkill. However, it's really obvious that you have your minus sign at the front, and it's really obvious what your complex number is, what your centre of the circle is. And if you do it this way, I think you're less likely to make small cock-ups. So please do it. It does make sense, and it really shows the examiner you know what you're doing as well. You're really saying to them, I know I need to have it in this form, and I know this is going to be the centre of my circle. It does help, and it shows a good level of understanding. So let's just do this one as well. So minus 5 plus 0i, oopsie daisy, I should have gone for something different, shouldn't I? Let's just try that again. I haven't got a rubber. Let's just do it down here then. I need my choice of examples wouldn't last too long. Okay, so it's going to be minus 5 plus 0i, so let's say minus 5 is about here. 0i, so it's not up or down, and I want it to be of radius 3, so that's minus 5, let's say that's about minus 2. Not my best circle. I do have a compass somewhere, but this pencil won't fit in it. That's minus 2. One thing you can do just to try and signify the radius a bit more is things like this, 3i, minus 3i. I'm not convinced you should be writing those i's there. I'm going to check that in a moment. With this one, though, it's quite obvious what the radius is because the minus 2, as long as you write that one in there. Okay, so that's how to draw the simplest loci we're going to do today. Just things of this form. Can you guys, for me, have a quick go at exercise 5.3 and just do question 1? Pause the video, check your answers, and then come back to me in a minute. Thank you. Okay, so I hope that went well. Let's just finish off what we were doing for today then. We've got some other loci stuff to do today. You may have noticed on the exercise there's some stuff about argument. We're not going to do that today, we're going to do it tomorrow. Just do things called half lines. So next of all, we're going to look at a slightly different situation. So just imagine instead that we had, let's have z take away 2 plus I equal to z plus 1 minus 3i. Okay, so this time instead of saying I've got some circle equal to some amount, I've got some circle equal to some other circle. So the best way to think about these, if you're going to explain them to somebody else anyway, you don't need to write anything like this down in your exam, is imagine this first one has some radius r. So in other words, the distance between z and this is some value r. The other one, let me just make sure that's written in the right way. So I've got minus 1 plus 3i will get me there. Just double check that works. Minus 1. Oh, no, it doesn't work, does it? Minus 1. And then minus 3i. That does work. Good. Equal to r as well. If this one's equal to r and they're equal to each other, then this one must be equal to r as well. They must have the same. So what we're going to do is we're going to just draw these, and I've nipped downstairs and got a compass. So let's see if we can do this. 2, 3, 4, 5, 6. Okay, so let's just mark these on. I've got 2 plus I. Let's go there. And I've got minus 1 plus 3i, so let's go up there. So these are my complex numbers. Now I don't know how big r is, so I'm not really sure how big to set my compass to. So this is going to go over some of my work probably. Let's set it slightly bigger than half the distance between them. So oopsie daisy. Ah no, go back up. Oh. Okay, if I set it slightly bigger than halfway, for instance, so I'm saying that's r. Well, if that's r, then I need to do the same r for this side too. Oops, daisy. Turns out I can't use a compass. Okay, so there's an r. I wonder if it matters if I pick a different r. Let's pick. Oh, in fact, actually, let's not do it. You guys can do it with different variants of r. Make it really big and just see how it works. What you're going to find, though, is it doesn't matter how big you make these circles. No matter how big you make these circles, you're going to get these 2 points which overlap. And if you draw a line through those points, like so, then what I am saying is that all of the complex numbers that lie on this line satisfy this equation here. And that's because the two distances have to be equal to each other. And so the distance of this complex number to there is the same as it is to here. Likewise here, likewise anywhere else on there. If I say this one up here, they're the same distance to each other. These ones are also the midpoint here. It doesn't have to be a fixed distance away from either complex number anymore, as long as the complex number I pick is the same distance from both of these centres. So this one here is the same distance from both of the centres. So if you get this sort of question, The way to go about it is by drawing your Argand diagram, and if it says to you, show on an Argand diagram all of the complex numbers that satisfies this equation, draw your two circles, it doesn't matter how big or how small they are, and draw a line through where the two circles intersect with each other, and that gives you all of them. I don't think your specification, I'll have to double check, I don't think your specification goes quite as far as asking you to find out what the equation of this line is or anything like that, but it's relatively simple. You can find out the midpoint, so you can find a point on the line. You could work out the gradient of the line between these centres. And if you know the gradient between these centres, you can find the gradient of this line because they're perpendicular to each other. So if you've got a point on the line, you've got the gradient of this line, you can work out what the gradient, what the equation of the line is. So it's not too tricky, I suppose. Okay, so I don't think we need to know anything else currently for the rest of the bits of the exercises I want you to do today. I'd just like you to practice that a bit more. So I need you guys to go away and do exercise 5.3, and can you please do question 3, question 4, I anyway. 5 I think it is. Yep. That's just reminding me I need to say something else. Question 6. Question 8. I think for now that will do. Okay, so just one thing I've missed out, which I should have mentioned earlier, is some amount of shading that goes on. So for instance, if you are asked to do, let's say for Z, take away whatever, 2 plus 3I is less than 1, then obviously I'd need to draw this as normal, as if it was an equal sign in the first instance. And 2 and 3I, so let's say that's about there. If this is an equals, I also draw just a line and don't do any shading. If this was a less than or equals, then I would draw a solid line and shade everything inside the circle. And if it's just a less than, similar to the work you did at GCSE, you will do a dotted circle instead and then shade inside. And that's more than enough for today. Please have a go at those questions. And also on the VLE, I'm just going to upload a RISP task. If you find yourself you can't stand not having any more maths to do before Monday, then please have a look at the RISP task and see how you get on with that, and I'll post the answers up to that on Monday, if not before. Have a lovely weekend, and I'll speak to you guys again soon. Bye-bye.